Hey guys, this is Mrs. Harbin, and this is Pre-Calculus Chapter 4. Today we are looking at 4.2, which is operations with functions. Now, I think that this lesson will actually be pretty quick. I've been doing two parts for almost all of the past few lessons, and I'm pretty sure I can get all of this in one lesson. In the previous lesson, we looked at increasing and decreasing functions. We reviewed the vertical line test to determine if something is a function, and then a specific subset of functions, the one-to-one function, using the horizontal line test. Today, we're going to do some operations with functions. Whoops, sorry about that. Our biblical integration for this unit is that God made angles a part of our world. They represent a place where things come together, as well as how things are oriented to each other. Unlike lines, which are infinite, angles show God's use of a finite system of measurement. And we've been talking repeatedly how we are using all of this information not just to pass the pre-calculus test, but to go out and represent real-world data. And we're starting to take all of this foundational piece that we've been learning about functions and apply it to some real-world problems. Our lesson objective for today is that you, the student, will add, subtract, multiply, and divide functions. Thus, find composition of functions. So we have our four main operations and a new operation called composition that you'll be learning about. Let's do a quick review. Evaluate the function f of x equals x plus 8. Given this domain, x is 1, 3, negative 2, and 8. Hopefully remember that you're just going to plug and chug here. So every time you see an x, you're going to plug in this number and evaluate the function. So for f of 1, we replace or we substitute 1 in for the x. Write the rest of the function. The function was x plus 8. Okay, so f of 1 equals 9. Okay, what about f of 3? Hopefully you said 11. 3 plus 8. F of negative 2. Plug in the negative 2. Negative 2 plus 8 is 6. F of 8, plug in the 8. 8 plus 8 is 16. So that's just a quick review on how to evaluate functions. But what if you see something like this? What would f of x minus 4 be? Well, you're still going to follow the same rule. Our original function is f of x equals x plus 8. And before we were given just a number, but now we're given an expression, f of x minus 4. So every time we see an x instead of x, we're going to substitute what's in parentheses. In this case, x minus 4 plus 8. If we simplify that, we get x minus 4 plus 8, which is x plus 4. So f of x minus 4 is x plus 4. All right, let's talk about the operations that we can do with functions. We can perform any of the four basic operations with functions. We can add them, we can subtract them, we can multiply them, we can divide them. And it doesn't, this chart looks a little complicated, but we're going to show visually what happens when we add functions. Now, we don't have to create this chart every single time. There are a much simpler way to do this, but this is going to show what we're actually doing when we are adding functions. So for f of x equals 2x and g of x equals 4x plus 7, let's say I want to add f of x plus g of x. So I could first plug in the values for the domain. So let's say do that here. So our domain values are 1, 2, and 5. When I plug that into f of x, I get 2, 4, and 10. So here's our range of f of x. When I plug it into g of x, I get negative 3, 1, 13. So there's my range of g of x. And then I'm going to add those two things together. Add all those numbers together. 2 and negative 3, I get negative 1. 4 and 1, I get 5. And 10 and 13, I get 23. So my range of f plus g is negative 1, 5, and 3. So again, it doesn't matter if I add them first. So I could have added these two things together first and then plugged in my domain values. I can plug in the domain values individually and then add them. The end result is the same. If I had added these first, I would have gotten f of x plus g of x is 2x plus 4x minus 7, which is 6x minus 7. And if I plug in those domain values, 6 times 1 is 6, minus 7 is negative 1. Plugging in our 2, 6 times 2 is 12, minus 7, that gives us 5. and plugging in our 5. 6 times 5 is 30, minus 7 is 23. So you could have evaluated them each individually and then added your range values, or you could have added the functions together first and then plugged in. I think that this is the easier way, and that's typically how we're going to do it. So when we're doing our operations with functions, it's going to look like this whenever you see the notation. F plus g of x can be broken into f of x plus g of x. F minus g of x is the same thing as f of x minus g of x. And f times g of x, take f of x and multiply it by g of x. Our fourth operation, division, looks like this. F divided by g of x. It's the same thing as f of x divided by g of x, as long as g of x is not equal to 0. If g of x is equal to 0, then it's undefined. And we don't have undefined points in functions. Let's do some practice here. We have f of x equals x2 minus 9, x squared minus 9, and g of x equals x plus 3. Let's add these two functions. F plus g of x. So we are going to actually add these two functions first. Let's see what that looks like. F plus g of x is the same as f of x plus g of x. F of x is x squared minus 9, and g of x is x plus 3. And notice that we are putting these in parentheses here. G of x is right here. We're then going to make sure that we add those together. Parentheses are important when we're doing subtraction because we would have to distribute that negative, but in this case, there's no negative to distribute. So we get x squared plus x minus 6, and that is our final answer. We have added these two functions together. Let's let f of x equals x squared minus 9 and g of x equals x plus 3. Let's find f divided by g of x. We know that f divided by g of x is the same thing as f of x divided by g of x. Okay, again, we know that our domain cannot be equal to negative 3. Down here at the, our g of x cannot be equal to negative 3 because that would give us an undefined function. Now we're not quite done because we can simplify this a little bit. We know that x squared minus 9 is x minus 3 times x plus 3. We can factor that out. And then we have x plus 3 divided by x plus 3. Those will cancel, giving us our final answer of x minus 3. Let's try this one. F of x equals 5x minus 7, and g of x equals x squared plus 3x minus 2. Let's find the f of a plus b. Now you may be looking up here and going, but there is no a plus b. I'm not actually adding my function here. I'm just dealing with the f function, but I'm plugging in a plus b every time there is an x. This is very similar to that review slide. We're going to plug in a plus b every time there's an x, so we get 5 times a plus b minus 7. Don't forget to use parentheses when you're substituting in. We'll distribute to simplify that, and we get 5a plus 5b minus 7. All right, what about this one? Let's find g of 4a. Again, we're not adding or subtracting any functions. We're just dealing with the g function, and we're subbing in 4a. So every time we have an x, we're going to substitute in 4a, which looks like this. 4a squared plus 3 times 4a minus 2. That gives us 16a squared plus 12a minus 2. All right, again, we're not adding or subtracting, multiplying or dividing any functions. We're dealing solely with our f function, and we're subbing in this x squared minus 9. So every time we see an x, we will sub in x squared minus 9 using parentheses. So we're left with 5, x squared minus 9 minus 7. That's 5x squared minus 45 minus 7, 5x squared minus 52 in its most simple form. All right, now there is a final fifth operation on functions that's called composition. And composition is where a function is substituted into a second function. Think about those Winnie the Pooh nesting dolls that I have on my desk, right? You've got one inside the other. So I think it's Piglet in the center, who's inside of Eeyore, who's inside of Owl, who's inside of Pooh. Okay, you've got one inside the other. So in a composition, you're taking one function and you're substituting it into another function. The notation looks like this. G with this little circle f, which is read as the composite of G with f, or it'll be written like this. You can see we've taken this f function and we've substituted it into the g function, and this is read as G composed with f. Now, sometimes you'll hear me say G of f of x, because sometimes that's just what I say. It comes out easier than G composed with f. So if you ever hear me get lazy and say G of f of x, that's what I'm talking about, G composed with x. Okay, again, this is read as the composite of G with f, or G composed with f. All right, let's look at an example. F of x is going to be 3x minus 5, and G of x equals x squared minus 9. And here's our given domain here. Okay, this is going to be what it looks like using our mapping diagram. Again, we won't use a mapping diagram every time, but this just shows what's happening. So we start with the innermost piece. So if we are finding G composed with f, we're going to start with the innermost piece, this f of x, and evaluate it first. So when we evaluate f of x for this domain, 5, 3, negative 1, and 0, what we get is this range. We're then going to take this becomes the domain of G, our outermost piece, and when it gets plugged in, we get this range. So our final answer is written with the original domain and this second range over here. So we did the innermost piece, and then once we did the innermost piece, we did the outermost piece. So we started on the inside and we worked our way out. Now, we're not going to do a mapping diagram every single time. We are going to do this with kind of an algebraic shortcut. So let's find G, the composite of G with f, if f of x equals 3x minus 5, and G of x equals x squared minus 9. Now again, this is G composed of f of x. So just like before, when we had like a G of 5, everywhere we had an x, we plugged in this 5. Well, in a composition, everywhere we have an x, we're going to plug in what's inside parentheses, in this case, the f of x function. So every time we have an x, we're going to plug in this f of x. So our original, we can write that as G of 3x minus 5. Since f of x is 3x minus 5, we had x squared minus 9. Oops, sorry about that. So when we plug in our f of x here, 3x minus 5, plug that in, 3x minus 5 squared minus 9. We'll simplify that, and we get 9x squared minus 30x plus 16. So I took one function and I plugged it into the second function. So took that inner piece and plugged it into the outer piece. We'll do several more of these examples in class to make sure you have the hang of it. But today we added, subtracted, multiplied, and divided functions, and we found compositions of functions as well. We will continue to practice those in class, but if you have any questions, be sure to write those down and ask me next class.